Well, I say the shorter the introduction, the lower the expectation. So that was good. It is an appropriate time, and when I first got asked to come down here, we didn't know about Hurricane Sandy, but now that it has hit, it definitely sort of raises a lot of people's awareness of what can happen and the difference between a short-term event and a long-term rise in sea level where we're arguing about tenths of millimeters per year, which really doesn't matter very much when you've got a storm surge of 14 feet because those millimeters get lost in the background noise. So I'm going to talk about some of that at the end of the talk, including this NRC committee sort of findings. But it turns out there's actually a number of other extreme events that we can worry about. This happens to be one in 1988 in Mission Beach in San Diego, and you almost don't have to say anything when you see these people standing here going, oh my God. And it's interesting, already in New York, somebody has proposed, a consultant who's actually at the university, a wall around Manhattan for $15 billion. And people are talking about how they're going to rebuild, and let's get that FEMA money and rebuild. It's not step back and say, is this a good thing to do? Sort of like Moss Landing moving up here. So one of the things that's clear to anybody that lives in California, not so much here, but particularly you get into Southern California, is there's a lot of stuff right on the water, within a few inches, within a few feet of sea level. A lot of really valuable real estate. Most of California's people live in coastal counties. And sea level rise wasn't an issue at the time most of California's coastal development took place. So when we think of extreme events, certainly what just happened in New York or on the East Coast was an extreme event. So we can call these either catastrophic events or extreme, depending on what it is. And those things we really can't predict very well. Some people calculate probabilities based on if we've got so many hurricanes and so many of a certain size. Others, we can't really do much about at all. So things like asteroid impacts, almost random events, ocean overturn, which we've had some record of, subduction zone earthquakes and tsunamis, coastal landslides, and then major El Nino events, as Erica mentioned, that coincide with high tides and storm waves. It was we had in 1982. So this is Manhattan. It's amazing with Photoshop, you can do all kinds of stuff today. But when I show these to people in the real estate profession, and they all gasped and said, no, this isn't really, it's a Photoshop, and they feel so relieved. But it's sort of like when you give a student an F, and then you give them a D, and they feel really happy about it. So you kind of bring it back down. These are all what we now know to be asteroid or bolide impacts. And we think of a few, but we don't generally know about many of these. Recently we've discovered Chesapeake Bay was formed from an asteroid impact about 35 million years ago. We think of the big one in Yucatan, 65 million years ago. One of the few that is sort of left an imprint is Meteor Crater in Arizona, 50,000 years ago. It wasn't very big, but it left a big hole in the ground. Things like that do. There's lots of visualizations of the one that hit the Yucatan Peninsula 65 million years ago. Lots of evidence from the ocean drilling program about what happened. Stuff scattered all over the continents, the fossil record, whether it was plankton or dinosaurs dying out. But that was an event that we couldn't have predicted, and there's great movies about this stuff, Armageddon and Deep Impact, and we can go out there and we'll see. But those are really extreme. Another, this is Jim Zakas at Santa Cruz, and this was in National Geographic, but it's what we now call the PETM, the Paleocene-Eocene thermal maximum, 56 million years ago, sort of hothouse Earth, when something happened to sort of double the CO2 content or add at least 500 parts per million very quickly. And we can tell from ocean drilling what the biotic impacts were, how that affected ocean acidification, how long it took to recover. But one of the things about ocean drilling is that we get these snapshots of events in the past that tell us what might happen again, independent of human activity. And this is a big one. How would we respond to that today? Well, we're screwed, basically. So we'll just leave that as it is for now. Something we have seen in recent years, large subduction zone earthquakes and tsunamis. This is probably not too much different than Manhattan looked like on Monday night. But a tsunami that was higher than anybody was really expecting, although there were records of similar such events, and there's some incredible photographs, but you know, maximum elevations of 60 feet and water running 3 miles inland. How do you really prepare for that? You know, ships tossed around like toys, and we've had a couple of big ones in recent years. The one in the Indian Ocean, and then in Japan. It's amazing, the morning that this tsunami hit, I had heard about the earthquake the night before, but only sort of in vague terms, and we were driving to Sacramento that morning to testify to the Ocean Protection Council in Sacramento. As we went over the crest of Highway 17, there were all these cars up there, hundreds of cars. And everybody standing outside with kids, and they were all Hispanic. And it turns out they'd gotten this message, go to high ground, there's a tsunami coming. So everybody drove either the top of Hecker Pass or the top of Highway 17, which is probably better than not doing anything. But at least the system worked, that just the message and the magnitude wasn't clear. But a lot of people, you know, we knew how long that wave was going to take, or those waves, to get to the West Coast. So this is sort of entering the Santa Cruz Harbor. A lot of people taking a lot of pictures and videos. And I think the damage was, I don't know, $17 million. But, you know, boats that were destroyed, and the docks that were pulled up and mashed around. The other big place is Crescent City. Crescent City is very odd because the harbor faces south. But even in the Alaskan earthquake in 1964, and these are images of sort of what happened in 1964, even though it faces south and the tsunami came from the north, somehow with refraction, it really battered Crescent City. 11 people died. And what I think is fascinating, in the last 200 years, 16 lives have been lost from tsunamis in California. It's like a good weekend on Highway 17. Many fewer than things like, you know, pit bull bites, or probably people die from their cell phones talking that many every day. So tsunami risk is really low because those events don't occur very frequently. And on the California coast, we're fairly insulated. Even when you go back in time, you know, highest elevations might be a couple of meters or a little more in Crescent City. But it's an extreme event that will happen. The biggest hazardous is probably Cascadia, which every 300 to 500 years lets loose. It's been 312 years since the last one. So the Oregon coast is much more susceptible to that than we are, but it will definitely be an extreme event. So while we're talking about earthquakes, on the terrestrial side, this is Moss Landing in 1906. And I hesitate to remind you from 1989. This is actually Jetty Road and the Marine Lab. So there's a long story of why Moss Landing was built where it was, out on the sand spit to begin with. And I got involved after the earthquake working with the state architect's office because they were trying to figure out, was this a safe place to rebuild or not? And one of the things that was interesting that happened, the seawall, and this was John Martin's office, the director's office, seawall had been there for quite a few years, never had a problem, but I think from slumping in the canyon head, the refraction pattern changed, and all of a sudden waves started to encroach, undermine the wall, and that, in addition to lateral spreading of the sand spit, which is exactly what happened in 1906, over it was probably an old slough outlet channel, really, I mean, completely destroyed the lab, and you all know the history. So very, very sad, but a very seismic shaking prone site. Another thing we don't often think about are large coastal landslides, either generated by large earthquakes or prolonged rainfall. I was up giving a talk in San Francisco on Friday and came back. It was a beautiful day last Friday, so it came back down over Devil's Slide. And I don't know about you, but every time you do that drive, you go. And it's basically a big slide. And what Caltrans has done over the years is continued to sort of drill inch diameter, 2-inch diameter holes and shove long pieces of rebar in and then grout them in, hoping, sort of like taking a stack of cards and trying to stick them together with pins, hoping it'll stay there until the next event. But what's fascinating, anybody know about the old Ocean Shore Railway? So back at the turn of the century, they decided to make a railroad from San Francisco to Santa Cruz down the coast. They laid the track except for the section along Waddell Bluffs. At that point, they could never figure out how to get across Waddell Bluffs. There was no highway there. They ran a wagon and then an old Stanley steamer along the bluff at low tide to get from one side to the other. They ran the track from Santa Cruz up to Swanton. Big gap in the middle. 1902, 3, 4. 1906, earthquake happened. But if you can believe it, you see this little, that was where the train went. In fact, the next picture is taken from here, looking towards, you know, you go through that cut as you go on. This is the train going, which is about where the road is, but they came across that entire slide. They built a railroad across there. In fact, after the earthquake, they rebuilt it. There was not enough traffic. They were going to develop the coast. It turned out to be sort of a fatal, well, it wasn't fatal. It just never happened. But people at that time, you know, were good at just, you know, sticking stuff on the side of the cliff. But every time I go back and think about building a railroad across that landslide, it's pretty amazing. And you may know now, the tunnel is just about done. I think they finished the whole thing. They've done an amazing job of making this sort of artificial rock. It looks like you're entering sort of the Flintstone cave. It's really kind of cool, but that'll leave that landslide behind once and for all. And there's other places. This is actually a coastal bluff just north of Ventura, the ocean. They're sitting on a little bench here, but this failed in 1995. I don't know how many people died, but it covered a number of houses. They built a retaining wall. And then in 2005, it started raining like heck. A series of mud flows, debris flows came down out of the coastal hills. It actually stranded motorists halfway in between that had to wait till the mud subsided. But ultimately, the whole thing gave way again. This time it buried 10 people. And in fact, this was the retaining wall. It really was not a match for the scale of that. So coastal bluff failure is not that uncommon. Along Monterey Bay, we don't see large-scale failure. We see shallow slumping, sloughing, but nothing on this scale. Another one, this is down at Torrey Pines. So this is sort of the back edge of that scarp. And people are building just behind the headscarp. I don't know where the Coastal Commission was on that one. But this is large scale. That's not something you want to have happen. And if you go, you know, you see these amazing houses built on these little, people may know the National Marine Fisheries Lab at La Jolla. And there's this sort of curious looking mound right here. And it turns out that's actually a slide mass. There's also a fault that goes under here, the Rose Canyon Fault. And I had a PhD student maybe 10 years ago that did his thesis on coastal erosion in San Diego County, part of a FEMA study. And he said, I can't believe it, but there's a fault that goes right under this building. In addition, there's a large landslide right in front of it. And if you've ever been in that building, it's sort of a spectacular location, but then it drops, I don't know, 180, 200 feet down to the beach. So I brought this to their attention. They didn't really want to deal with it. Well, this is now a new NIMS building. So I think the help of Scripps and their congressional staff, they got money for a new building, and they're now going to take this down and build it further inland. So it's sort of hard to deal with landslides on that scale. They aren't necessarily that common, but when they do occur, there's not a whole lot we can do about it. On a more sort of, well, on a smaller scale, we see a lot of cliff and bluff erosion that happens, you know, on a regular event, sometimes daily, sometimes during big events. You may have seen Pacifica in 2010. The bluffs in Pacifica consists of, we could call it some fancy geological name, but it's basically dirt. It's pretty young alluvial sediments that have come off the coastal. That may be a bit of a marine terrace, but it's unconsolidated alluvium, basically. They were hammered in the 1982 El Nino, the 1997 El Nino, and actually these apartments were built right on the edge. They were back a little further, but after what they do is they sort of buy and sell these repeatedly. And in this case, the guy had recently bought it, so what they're doing here is hanging these guys over the cliff, and they're now drilling back in, putting in tiebacks, trying to sort of screw the bluff together, and then putting a gunite covering over here. I haven't been back in the last 2 years to see how they're faring, but I think these are all red tagged, not to live in them. But this is the kind of thing that doesn't give you a lot of faith in sort of people's wisdom. I think economic clearly rules here, but there's a lot more in Pacifica that was built, you know, on the edge of a very actively eroding bluff, and this rock probably isn't going to make a lot of difference in the long run. We've done work with, sometimes you tell people, well, the cliff is eroding at 12 inches per year, or an average of 6 inches per year. It doesn't really mean very much. So we did a book on the coast of Santa Cruz then and now, and so we found a lot of old photographs. This was 1909, and if you know Santa Cruz, it's on the west side, so we're kind of between Steamer Lane and Mitchell's Cove. Interesting structure out here, which was one of California's first wave motors. Won't go into that. So 1909, here's a guy sitting out here on the point, and 2006, it's gone, and we came out a couple years later, and it had been completely eroded. So we decided to kind of put the guy back out there again, just to, so people could see how much you can really lose over the course of time. And Santa Cruz is great for this because we have natural bridges that had 3 and 2, and now there's 1, and easy in some place to document what's happened. One of the challenges is, in many cases, you can't stand where the old picture was because there's nothing there to stand on anymore. So as close as we tried to reproduce the photos, sometimes that's difficult. Another place you may know, Capitola, Crest Apartments. These were built actually in the late 60s, not that far from the bluff edge. I had worked with them over the years trying to figure out, can you stabilize this? They thought of all kinds of walls and structures, detached offshore seawalls. They put in these caissons down to bedrock, but then during the '89 earthquake, the bluff failed, cracks went through the foundation, so FEMA took these down. They took down 8 units, but as you proceed from there to New Brighton Beach, probably one of the most rapidly eroding sections in Santa Cruz County and one of the most difficult to do anything about. So this is the edge of that apartment unit. There actually used to be another house here, but the rock unit there, pretty young, the Perisma Formation, it's the formation that has all those mollusk shells that everybody has on their desk someplace in Santa Cruz. It's also, though, very pervasively jointed, so there's a joint set that runs parallel to that stretch of coast that dips about 75 to 80 degrees seaward. And then at the base of the bluff, well, you can see people here for scale. There's actually a very weak unit that keeps getting under. So we lose the support at the base, and then these slabs that are somewhat almost like dominoes just keep collapsing. So it's a very difficult place to do much about, but people are still building. But if you go back a few years, and this is thanks to the Coastal Records Project, this is 1972. So here's the house that was moved back, but there was a street that ran all the way the length of Depot Hill called Grand Avenue. And in fact, at one point there was back in the turn of the century, there was a lover's lane out here with 2 rows of pine trees and benches and very lovely, that are all gone. So you look at it today, well, all that's gone. This is all gone, and people are buying and selling these quite frequently. I have a friend who lived in one of these houses, and there's no front yard now. The bluff's maybe 20 feet away, and I went there for some event, and I didn't know where he lived. I went to the house, and I said, Tom, why didn't you talk to me before you bought this house? This is what I do. And he said, Gary, I didn't want to know. He's a retired airline pilot, loves the house, not going to worry about giving it to anybody when he dies. So he said, I'm just going to enjoy it as long as I can. So it was a different viewpoint than what I had expected. Just to the east or down coast, there's another apartment complex that was for sale. And I got a telephone call about 2 years ago from a realtor, and they said they had a apartment complex in escrow on Depot Hill. And I said, oh, is it the Antigua Apartments? And they said, yeah, how did you know? And I said, oh, I know these things. And they said, do you think there's any concerns I should have about selling it? Because I have a buyer who's very interested. And I said, well, are you at a computer? And he said, yeah, right in front of him. I says, well, just type in CaliforniaCoast.org. Does everybody know about this site? Maybe not. Well, type it in. No. Does anybody hear about the Barbara Streisand lawsuit? Does anybody know who Barbara Streisand is? Well, it turns out there's a couple, lives in Corralitos, did very well in some software businesses, and decided they were going to try to do something sort of environmental to help the coastline, because people they thought were building illegal seawalls and stuff. And they said, well, what if we took pictures of the whole coast to document it? And somebody said, that's a great idea. So they have a helicopter. They flew the entire California coast with very high resolution digital images from the Oregon border to Mexico. 2002, they came back and did it in 2005, 2007, 2008, 2009, 2010. These images, you can see Moss Landing Marine Lab, you can blow it up 3 feet on the side. He's got a satellite navigation and a digital camera. I, turns out, had 2 sets of colored slides of the entire California coast from 1972 and 1979 that state agency had taken that I'd gotten a hold of. I asked him if he wanted to work with me on them, and so we scanned 14,000 slides, put them on, and then he's added some from the Coastal Commission. So now you can go in to any site in the California coast, hit time comparison, and see what it looked like in 1972, 79, 85, 87, 2002, up to the present. It's an incredibly useful tool. You can just kind of fly down the coast. So I diverge. So he got this on. I said, well, type in this number, because I knew the image number. All of a sudden I hear this. Oh, shit. He had no idea. They were standing up on this balcony. You know, there's, I don't know, 3, maybe 12 apartments. You know, it was probably $5 or $10 million. And he didn't quite know what to do next. But one of the things that, it's part of that joint set. So this is a shore parallel joint set that dips seaward, which is a pronounced zone of weakness. So these slabs might be 2 feet or 3 feet or 5 feet thick. And you can see a big chunk has collapsed here. There's also intersecting joint sets that run right angles to the cliff edge. So not only are these like slabs, they're slabs that have been cut up again. You walk that stretch. It's a fun stretch to walk at low tide. Just don't walk right along the bluff edge. But the prisma is full of both mollusks, and you can see these incredible layers that are just packed full of shells. And there's also a lot of mammal bones. You see a lot of whale bones in there. So it's an exciting place, but I do not know what happened, if he sold it or not. But clearly, this is a difficult place to protect. So I don't know whether he used the site anymore or not. But and then, so those are marine erosion. We've also got terrestrial processes. This is Rio del Mar. And this was actually failure at a place called Place de Mer. Manresa Beach is just up here, and then down to Sunset and so forth. This failed during the earthquake. But the bluffs, about the outer 2 or 3 feet, just sloughed down. Actually, this house was destroyed. In fact, on the way down here, I was just looking at a house somebody has for sale on the bluff a little further around to see is this safe or not. Up coast a little bit further on Beach Drive. This was during the winter of 1982 when we had the 100-year, 28-hour rainstorm. So they were building a bulkhead to actually protect the sewer line, but also these homes, but they weren't thinking about the bluff behind them. So this intense rain, this bluff failed, pushed this house into the street. Guy was actually sleeping in the house at the time. Said something about a dream. He had a dream. He turned around and sued. This guy saying he was to blame, and he sued him, and probably the lawyers made money, and neither one came out with anything. But interestingly, this site today, I don't know if I put that picture in here. Yeah, that house has been replaced by a duplex. So what the county is requiring is them to supposedly engineer the roofs of these houses to take the load of the overlying hillside if it comes down on them. But you can imagine these are really valuable properties, but you know, how much do you have to know before you say, gee, maybe this isn't the safest place? But it happens. It happens repeatedly. And then there's places in Southern California where the intensive development is even greater. Solana Beach is one of those. They've been struggling with, you know, do we armor, do we protect? But they've got a lot of high density, high cost development. This is, again, from the Coastal Records Project in 2002, 2010. So you can just see the setbacks a little less, and they started to sort of patch this in. And then the next extreme in Encinitas is you just build walls. And California's coast now is about 10% armored. But if you look at Southern California's four major counties, well, four counties, San Diego, Orange County, Los Angeles, and Ventura, 1/3 of those entire counties are now armored with structures of one type or another. And there are impacts of those. Coastal Commission is getting increasingly reluctant to approve any more of these for a number of reasons. But probably the biggest impact is that as sea level rises, the shoreline is so the beach is going to get lost. So at the cost of saving private development, we're going to start to lose public beaches. And with 30% of Southern California's coast armored, whether it's a seawall, a parking lot, a road, a railroad, a hotel, they're all keeping the shoreline from migrating. So it's a big impact over time of sea level rise. It's not a controversy in the sense that is it going to happen or isn't going to happen. It is going to happen. Even now around Monterey Bay, there's a handful of places, the Monterey Beach Hotel, Ocean Harbor House, Sand City, where they've dumped concrete over the cliff. Where at high tide, you cannot walk along the beach. Used to be in front of Stillwell Hall at Fort Ord, the same thing. That's now been taken out, and you can walk along the beach again. So that's a long-term impact of these kind of structures. Another issue that's come up recently is how about extreme waves? Are West Coast waves getting larger? Well, we never heard about Mavericks until 20 years ago, and now we hear about it a lot. In fact, they just came out with a movie this week on Maverick story. So the records from the wave gauges off Northern California, Oregon, Washington clearly show the waves have been getting larger over the last 35 years. There's some question about, is that a change in climate? Are the wind patterns changing? The people up in British Columbia who measure them say, we changed the sensors on the wave gauges, and it's an artifact, at least off British Columbia. But there's no question that the waves that have been recorded off Oregon and Washington are getting larger, and they're getting larger faster. USGS, Eric and I were talking about Kurt Storlazzi, who was the author of this, actually looked at the Central Coast and found the average wave height over the 22-year period from 1980 to increased, 1.4 feet, the average wave height. Is that a big deal? Well, it depends probably on what happens next. So we just looked at some of the wave records, and this is for Central and Northern California from 1984 to 2010. These are the number of occurrences of waves that are greater than 5 meters in height, roughly 16 feet, and the red are waves greater than 20 feet or 6 meters in height. So when you see that, is anything that look like anything's changing? What is important is we didn't start measuring waves till the late 70s, some places the early 80s. So if we look at the climate, the period from roughly 1945 to 1978 was a cool PDO cycle. Generally, less severe climate, less rainfall, less storm wave activity. So that entire wave record is during a positive or a warm PDO cycle, which I would expect to have larger waves. So we don't have a long enough record to say this is changing. Certainly as wave heights increase and sea levels also going up, we're going to see greater impacts, waves reaching further inland and to higher elevation. So this is something we need to continue to monitor, although as budgets get cut, we shut off wave gauges. So sea level rise is obviously a topic that people are beginning to think a little bit more about, maybe after this hurricane a little more so. And you may have followed some of what the East Coast states have done recently. I don't know if this is something you follow, but North Carolina decided to basically outlaw sea level rise. They thought that there was no certainty, so they passed legislation that said any future coastal development, state agencies, whatever, can only use the historic rate of sea level rise with no increase. So they're going to use basically 1.7 millimeters per year, or about 8 inches over the last century. And I'll show you what's happening. But politics is very powerful. I think Steve Colbert had a whole program on this, saying, if you watch that kind of thing. Virginia, equally enlightened, I'm sorry if you're from Virginia, they decided that sea level rise was a liberal, progressive, democratic word, and they outlawed the use of sea level rise and decided to use coastal flooding. So California is, without question, a leader in a lot of things. The governors of the West Coast have gotten together and moving forward on a lot of things, but we still have places in the country, if you want why people vote the way they do, that are thinking they can legislate sea level out of the picture. So long-term risk of sea level rise, I started with, is an issue because we've got a lot of development right at sea level. And it doesn't matter where you go and whether it's industrial or commercial or residential. So sort of the big picture of climate change, we're at a point on a trajectory that looks like it's sort of concave up, whether it's climate, temperature, sea level. There's a number of climate models, and they're all slightly different. And depending upon how you insert different values and then how far you go out into the future, there's some major sources of uncertainty. One is natural climate variability. One is the trends of future greenhouse gas emissions, which is huge. So what is India going to do in the next 100 years? What's China going to do? They're building power plants and pouring concrete rapidly. What are we going to do? Well, it depends on maybe who's in the White House. Just sound political. I mean, those are things we do not know. We don't know what's going to happen in the future, but that makes prediction difficult. And then how does the global climate system respond to those forcing functions, whether they're greenhouse gases or whatever? So I rely a lot on one of my favorite climatologists. And you may remember this quote, there are the known knowns, there are the known unknowns, and the unknown unknowns. And that's sort of where we are with climate. And in this NRC committee, we talked about all the uncertainties, things we know for certain. Was it Mark Twain? There are the things we know for sure and I don't know what it was. Things we don't know and the things we know for sure that just aren't so. So global sea level is rising primarily because land ice is melting and the ocean is expanding as it warms. Those are the two big drivers. And one of the things that the IPCC, the Intergovernmental Panel on Climate Change, in their last assessment, which was 2007, which included data up to 2006, all those models are really various ways to deal with ocean warming primarily, and they don't really fit in global ice melt very well. The committee I was on included two glaciologists that said, you know, right now it looks like ice melt in Antarctica, Greenland, as well as other glaciers around the world, which are moderate in importance or not as important, has gone from 1/3 of the signature to 2/3 of the signature. So that was a significant change. But what we can see is going back in the geological record where we've got tree rings and corals and all kinds of things, sea level didn't change too much between 18 and 1900. Between 1900 and, say, the global tide gauges averaged about 1.7 millimeters per year, which is really tiny, 8 inches per century. We launched the early satellites in the early 90s, and in that last period, the last 30 years, that's almost doubled to 3.1 millimeters per year. The thing that takes out of the equation is local land movement. So when we have a tide gauge in Crescent City where the land is actually rising, or in Alaska, sea level rise is negative because the land is rising faster than sea level. Alaska is rebounding from the ice age. But if you go to someplace like New Orleans where the land is sinking, it's much, much higher. So the local tectonic signature, subsidence, uplift signal was sort of making this number more difficult. When you average around the world, that's what we got. How we measure sea level down to 1/10 of a millimeter from space is more than I can understand. I just think these satellites up there, and we've got hundreds of miles and water moving around. How do we know that? Well, I can't explain it, but then I don't know how a cell phone works either, so that's okay. So recent sea level rise in California, the longest tide gauge we have is San Francisco. It actually goes back to the 1850s. There were some things happened here during the San Francisco earthquake and so forth. But you can see a signature that's about 2 millimeters per year, just about the global average. So San Francisco hasn't been moving too much one way or the other. But what's important here is there's these huge blips in here, which are El Nino events. And it turns out those short-term events are far more important, probably in our lifetimes, than the long-term rise in sea level for most places, except maybe those that are very low-lying. So these are these signatures from 1940-41. Sea level was almost a foot higher for 2 or 3 months. The 82-83 El Nino was 12 inches higher, and 97-98, almost a foot higher, 280 millimeters for 2 or 3 months. So if you think about a few millimeters per year, it takes you a long time to make up for that. In fact, I just did something simple. If this was to reach that level, 280 millimeters, it would take 140 years at 2 millimeters per year to get up to those elevations. If we double sea level rise, because we're now up to 3-something to 4 millimeters a year, it would only take 70 years. Or if we quadruple it, it's 35 years. So the whole point is, over the short term, it's these infrequent events. Hurricane Sandy is an extreme example of that. But along the California coast, it's this coincidence that we saw in 82-83, 97-98, and a number of other times with high tides, storm waves, a little bit of storm surge, and here we may get a foot, and El Ninos that are going to be the things that we need to worry about. So we can argue about what this rate is, 3.1, 3.2. In the short term, that's not really going to matter. So we have seen places where even now, high tides, El Ninos, storm surge, is going to inundate. This is Mission Beach in San Diego. And part of that is really where we are in these ENSO cycles. And what's sort of interesting, I should say PDO cycles, from 1940 to 78 was a cool or a negative PDO cycle. Climate was fairly benign. Not that we didn't have storms, not that we didn't have storms, but that's when most of California's coastal development took place. Between 1945, after World War II, all those servicemen and families coming to California and working in the aircraft and so forth and so on, came back from Chicago and Des Moines and Detroit and said, I want to live in California. So they developed the beaches, the cliffs, the bluffs, the dunes. 78, the climate switched, and we went into a warm or positive PDO cycle with the associated El Nino events, and all of a sudden people started looking around saying, wow, why did we build here? So property was subdivided, sort of like giving out the Colorado River water at a time when there's a lot of rain. All of a sudden now we know there isn't enough water. So these longer term cycles are really important, but we didn't understand those. And it's interesting, those of you that work in the fisheries areas, these are sardine rich times. These tend to be more anchovies. So when the sardine fishery crashed in the mid-late 40s, people thought it was DDT and overfishing. It turns out they came back. And there's a long history of coming and going related to these sorts of cycles, which I understand is related to different kinds of plankton, what they feed on and so forth. So January 83 was sort of nearly perfect storm for here. It wasn't what hit New York City, but we had an El Nino event, very high tides, large storm waves. In 2012 dollars, a couple $100 million in damage. This doesn't really compare to a big hurricane where they're talking about 20 billion or 30 billion, or Katrina was nearly 90 billion. But oceanfront homes destroyed, businesses damaged, and so forth. Pajaro Dunes. And this was sort of our elevated levels of the ocean. So from San Diego to Seattle, these were the predicted high tides above mean lower low water. This is what actually happened, and that was the difference. So a foot to, 2.5 feet above predicted. The highest in any of those years of record keeping. So what that does on a gently sloping beach is really move everything further inland. So the waves are now reaching places where they wouldn't have. And this is just that same event. Looking at January, February, March, this was the wave gauge from the Santa Cruz Harbor. This is the northern Monterey Bay wave gauge. These were the predicted high tides, even though it was maybe a foot above that. So what's interesting is if you look at, here was a storm with large waves that arrived at high tide. Here was another one, here was another one, here was another one, another one, another one, another one. So we had maybe 7 storms that came at high tide, and each one took a little bit more sand off the beach. The waves got a little closer to Pajaro Dunes or Rio Del Mar. So this was an unusual event, but it was that coincidence of things that really produced a great amount of damage. And you can look at places today that look wonderfully safe. Capitola in the summer. This was 1983, looking from Capitola back out to shore. Seawall was overwhelmed. Seawater came 2 blocks driftwood into the main part of town. Another Capitola, you may know this, they're actually condos. They're the oldest condominiums on the California coast, called the Venetian Courts. But they were built on the sand, which if you're a real estate agent is a really nice thing to be able to advertise. But during that winter, they all got drenched. In fact, it's coming into the restaurants along the Esplanade, which is all built at pretty low elevation. So if you add a foot or 2 onto sea level rise here, you can start to see we're not at problem here, but they have problems. This is Beach Drive in Rio Del Mar in 83. So usually there's a beach 200 feet wide, came up over this wall into these houses. In fact, most of these houses have plywood barriers they put up in the middle of this, the sandbags, and this is beach sand. They've got houses for sale on the sand. Sea Cliff is another interesting place because it's a state park with RVs and so forth right on the sand. This is the old Sea Cliff, but they encroached quite a ways out onto the beach. So September 2010, winter of 83. At this point, all of this debris has come over the top of that wall, logs from the San Lorenzo River and Soquel Creek. It got worse, and that's when I decided to leave. And when it was over, this wall had been built about November, October of 82. It was finished. Economically, it was going to last 20 years, which made sense. It lasted 2 months, and half of it was destroyed. And it turns out that's the 8th time that wall has been built and destroyed. And at a low tide, you can look out across the surf zone and see these progressive walls that have one by one been demolished. So this is a state park, so that's us rebuilding it each time. Another interesting site just down coast, via Gaviota. Aptos Seascape was one of the last developments like Pajaro Dunes built before the Coastal Commission. And this was all beach. They got permission to bulldoze down sand from the uplands here and put a terrace and build homes on it. They were actually going to do this for another mile down coast. And so for some reason that was halted. But the original plan was to put one row of houses here and then build a wall in the front so they would be protected. The last minute they said, you know, if we push those houses forward and don't put the wall in, we can sell another row of lots on the backside. But this development is out on the beach. So in 1983 again, the riprap that they had built sort of as an armor, which was supposed to absorb wave energy, acted like a ramp. And the waves came right up that riprap, right through the front of all those houses. These are moving vans. People are moving out. And the waves came right back up to the base of the bluff again. And afterwards, a couple of these houses collapsed. They all had plate glass windows, sliding glass doors, which don't really hold back the Pacific very well. Someone once said the Pacific Ocean is 10,000 miles wide. Doesn't really care about a few feet on either side. So they learned that, but then what followed was paid for by insurance, which is us, basically, a $5 million wall, which well, you can see they're rebuilding this, but they've been okay since then. But these are now probably $3 million houses. Over time, there will be issues, but right now, that wall is pretty substantial. So long-term impacts, gradually from 2050 to 2100, gradual flooding followed by more permanent inundation of low-lying areas. We would expect increased cliff retreat rates or bluffs and dunes because more exposure, more storm wave damage, particularly during ENSO events. And gradually where the back beach has been fixed, we're going to start to lose those beaches because we're going to basically flood them. So those rising seas are going to increase erosion, increase coastal damage, and the risk of coastal flooding. So how high might sea level get? This is some work done by Dan Kane at Scripps, looking from 2000 to 2100. These are some of the range in those models at that point. So 3 feet to 4.5 feet by 2100. Looks like these don't diverge too much for the next 20 or so years. This is actually the historic rate, about 8 inches per century. This is the present rate over the last 30 years. So will it double or triple? It's all those uncertainties. And there's some of the models, depending on what model you use and what greenhouse gas emission scenario. But there's SFO with a 16-inch rise in sea level. And SFO was built on fill. You say, well, why did you do that? Well, they weren't thinking back in the 50s about sea level rise. And you could say, well, I'm going to use the Oakland airport. Well, Oakland looks exactly the same. It was also built on fill. So they got the fill up above high tide, said, and the next time you go out of SFO, just look out the window at the edge of the runway and sea level, and they're pretty darn close. So this is not like an apartment building or, you know, a park. This is a big piece of infrastructure. How we will deal with that is not going to be a problem today or tomorrow, but it could be within 20, 30, 40 years. So those are big problems. And I mean, it's not only SFO, but lots of others. The Embarcadero today along the waterfront in San Francisco is seawater laps up there today at high tides. This is Balboa, Southern California, in the middle of summer. Very, very low. So there's a lot of places like this that we're going to see more and more of. Well, I had to throw in Hurricane Sandy. This is ground zero. It's like a river flowing in on this, you know, the lower Manhattan. Water just pouring over these structures that nobody thought would ever happen. This is one of the subway stations. So a big event that's going to have probably a profound impact. And already people are beginning to say, wow, maybe climate change is real, whether in fact this is related to that or not. So these were the numbers we came up with. I think this is the final slide from the NRC report. And this could look complicated. It's really not very complicated. These are the numbers for 2030, 2050, and 2100. And I just did these in centimeters. But this is the our global number. This is Vermeer and Ramsdorff, who've been using an empirical approach of sort of looking at global temperature and sea level rather than all of the things that go into that. That's what the state has been using. And then California and Oregon and Washington, which lie in a little different tectonic situation. So basically the numbers, and I'm going to do something here real quick to give you an appreciation. One way of remembering this is by 2030, the midpoint's about 6 inches. By 2050, it's about 12 inches. And by 2100, it's 36 inches. So 6, 12, 36, if you don't remember anything else. This is the range, but what it would take to reach that by 2030 would be an average of, this is going from today, 2000 to 2030, would take an average of about 5 millimeters per year. It's 3 point something now. So that's not too far off. It wouldn't take too much to do that. But the higher end would require a significantly higher rate. 6 millimeters per year would take us up to about 12 inches by 2050. If we get the upper end, it would be a bit higher. And by 2100, the midpoint to be 3 feet higher than 2000 would take about an average of 9 millimeters per year. This upper end is pretty high. Would we get up to 5.5 feet or 4.5 feet? We don't know. And I liken this projecting out in the future sort of like, let's see, those of you, if you had kids going to college that were going to go to college, and this is wrong age group, but would be for you. You're trying to, say your kids are 2 and 3 years old, and they're going to be going to college in 15 years. How much do you save? Well, tuition's changing really quickly. You could be off by a factor of 3 or 4. Or retirement. What's it going to cost in, for you guys, 50 years? You know? How far off would you be with all the uncertainties? And that's sort of where, this is the known knowns and the known unknowns and the unknown unknowns. So the future through mid-century, same kind of hazards we've seen in the past, but probably more frequent and more severe. Sea level alone will not be the big factor to cause significant erosion and flooding, but these rare events, or I shouldn't say rare, infrequent events with the simultaneous occurrence of El Niños and high tides and storm waves. Beyond 2050, when sea level gets to be maybe 14 inches above the present, then that ramp-around is going to really be additive, and whether it's erosion or flooding or inundation or low-lying areas being impacted, we're going to see more and more of that. So I think that's it. Oh, it's something here. Coastal climate, variability, uncertainty farther out we go. One of the main things we need to keep doing is measuring and monitoring, you know, what is happening with sea level. The closest tide gauge to us is Monterey, which isn't a long run, and in San Francisco, we don't know what's happening here. We could be sinking. Wouldn't surprise me. How about changes in beaches and so forth? So the two things that are really important are, is what we're doing sustainable, and what's the risk? And risk is a function of both the probability of an event occurring and the magnitude of the impact. And I think I put in two things here. Between 2000 today and 2050, this is sort of a risk analysis. So this is the probability of it occurring. In something that has a very low probability of occurring, and it doesn't really matter too much, it would be low. But the further we go out in time and the higher the probability of it happening, and the bigger the impact, the closer it gets into these red zones. This starts to begin to tell you, okay, an asteroid impact, high consequence, but really low probability. But over here we have cliff erosion, ENSO events, large coastal landslides, earthquake and tsunami. And then if we go from 2050 to 2100, some of these get over into the red zone. So those are the things that we need to begin to sort of think about, and maybe the places to put our effort rather than just panicking and dealing with everything. Thanks very much. How could you possibly have questions?
So if you go to these plannings that in the state of California, what are they actually planning to do?
Well, each of the agencies now is charged with responding to sea level rise. And you can imagine Caltrans. They've got roads and bridges that they're replacing. Parks and Recreation has parks and picnic grounds and bathrooms and water resources. The Energy Commission dealing with power plants. We've got sewage treatment plants, many of which are at the lowest part in the town at sea level. So they're trying to figure out what policies and what values to use. So they were very interested in knowing sort of what our projections were. And, you know, they said, well, should we use the higher or the lower? I said, well, there's a couple of questions. What's the facility? How long is it projected to last? What's its value? What's the cost of losing it or replacing it? So if it's a power plant like Moss Landing, let's just say you were going to build another one today, and it's going to last 100 years, you probably want to make sure it's above those maximum levels. If it's a parking lot, you can live with being inundated. So what that facility is. But each of them, Coastal Commission, every one of those agencies is now trying to coordinate a sea level rise adaptation plan, guidelines for their people to deal with. So they're taking it very seriously versus North Carolina where they're kind of outlawing it. Too bad this hurricane didn't hit North Carolina. Did that answer your question? Yeah. And then you want to know.
Around here, is sloughing from ice plant make any difference at all, or is that just tiny?
Is what now is?
Sloughing, like on coastal erosion from ice plant hanging over and everything like that.
Well, there's a lot that's been done on sort of bio-erosion control. And I think that's where coastal bluffs are not exposed to waves, but it's more terrestrial runoff. And you see that from here all the way to New Brighton, basically Sunset Beach. And it's a terrestrially dominant environment because we've got a beach that's 300 feet wide. It rarely gets hit by waves. So there, the native vegetation, I would say native vegetation, one of the best things actually is poison oak. It loves salt air, and it just really, ceanothus, there's a number of things. Ice plant sort of has its pluses and minuses. I mean, you get these huge clumps hang over cliffs and then bring stuff down. And I think the general tendency today is to try to get back to natives that don't need to be watered and have less impact. So,
I've been working on a project trying to restore native plants on west of Dragon's Sank.
okay. Yeah. Yeah. And there it's really, you know, a bedrock cliff that's 20, 30, 40 feet high, and the ice plant sort of grows on the sandy terrace deposits, which is sort of the littler piece of the picture. Not that you shouldn't do what you're doing. I think it makes us feel good to do stuff like that anyway, too. So enjoy what you're doing. Good, thanks.